Hi guys! So for today's educational vlog, we're going to study freefall. But before we go ahead in our topic, let's first determine our objectives for today's video. So our objectives for today are to determine and define the nature and principles behind freefall, define gravity, determine the formulas or equation that will help to further understand the topic, and lastly, provide sample problems to apply what we have learned in this today's topic. So, what is freefall? The gravity of the Earth attracts every object towards its center. When an object is dropped from a certain height, it begins to fall towards Earth's surface under the influence of gravitational force. Such a motion of an object is called free fall. In other words, an object under the influence of only gravity will keep falling with a constant speed and magnitude. Imagine this, you're holding in your left hand a stone and your right hand a paper. If you drop two objects with different masses, they will both fall with constant speed. But such thing won't happen in this case because there's a force that makes like object fall more slowly, and that is air resistance. So now that we have covered the basic principle and definition behind free fall, now let's talk about our third objective, and that is to determine the formulas behind free fall. But first, let's learn the terms and its corresponding symbol. T stands for time, V is for velocity, while V sub O is for initial velocity, D is for distance, and lastly, G is for gravity. And one more thing to consider in this formula, as we stated earlier that objects fall in constant speed or acceleration, the value for acceleration or G is always 9.81 meter per second squared or 32.2 feet per second squared. And as the object is falling, the value for gravity is always positive.
So now that we have established the formulas to use, let us solve the following sample problems to apply what we have learned so far. But before we start solving, let us first find the method where we can solve problems efficiently, and that is GRESA. GRESA stands for given, required, equation, solution, and answer. Let us start. A stone that starts at rest is in free fall for 8.0 seconds. Calculate the stone's velocity after 8 seconds. Now, let us determine the given. It is stated that the rock starts at rest, which makes our velocity, initial velocity, 0. And next is our time. Our time values 8.0 seconds. And next our constant, gravity, which values 9.81 meters per second squared. And next is for the required. The required in the problem is the stone's velocity after 8 seconds. And next is we're going to use what equation we're gonna use. Based on the given, we're gonna use the formula V is equals to initial velocity plus gravity times time. And now let us proceed to the solution. In our solution, let us substitute the values in our given in the equation. So that would make V is equals to 0 plus 9.81 meters per second squared multiplied by 8.0 seconds. And that would give us the answer 78.98 meters per second. And that's how you're gonna find the final velocity for this problem.
So, for the next problem, a silver dollar is dropped from the top of a building that is 1,362 feet tall. Find the time required for the coin to reach ground level. Let us first determine the given. Vi equals 0 feet per second. Distance equals 1,362 feet. And gravity equals 32.2 feet per second squared. In this problem, the required part is calculating the time. As the sum problem is pretty basic, we're only going to use one formula, and it is distance equals initial velocity plus gravity time squared over 2. As for the solution, we're going to show a step-by-step process. Okay, first write the formula. Initial velocity time plus 1 half gravity time squared, and then write the required, and then write the given in this solution. And then solve the given provided. The answer is 16.1 feet over second squared. And then solve the time squared. 1,362 feet over 16.1 feet over second squared. Square root of time squared equals square root of 84.6 second squared. And for the answer to this formula would be 9.2 seconds.